Today we'll be talking about tires. Some of the topic that will be covered today in our table of content is raw material, instrumentation, process and procedure, chemical involvement, and MSDS. First we have Caleb to talk about raw materials.
Alright, tires are made up of approximately 40% natural rubber. This rubber is found in the rubber tree. It comes out as a milky latex, as you see there in that picture, and it's approximately 30% rubber. The rest of it is synthetic rubber, which makes up about 60% of a tire. This rubber is produced in a petrochemical facility, and is most commonly styrene butadiene. Carbon black is also a resource that's put on it. It's to reinforce the tire, and it gives it that classic black color. Catalysts used in tire production are zinc oxide and stearic acid. They're used to activate the process of creating rubber as well as speeding it up. The zinc oxide increases the vulcanization rate.
The next spot we'll be talking about is instrumentation. So constant pressure, flow, and temperature measurements. Reactors are equipped with temperature indicators to monitor temperature profile. Temperature controllers control reactor temp for polymerization and prevent overheating of catalyst or reactor. Flow controllers to control production rate. Pressure controls downstream of reactor to maintain pressure. Flow and temperature are controlled in tire production. Temperature control to allow rubber to be flexible and easy to mold. Flow or speed controllers on conveyor systems to adjust rate of production. Tire recycling. Used tires ground up into a fine powder. Shredder and granulator used. Steel belts removed using magnets. Rubber powder is known as crumb. Finished product used in new tires, construction materials, binders, and running tracks. Here's just a flow diagram of the tire recycling process as it goes from a tire to a finished product where these tires are shredded and the rubber belts are removed.
So next we'll be talking about procedures. The first procedure in this process is weighing the raw material. First, the materials in the tires are mostly 80% are made out of synthetic rubber and natural rubber. The rest of the materials consists of carbon black, which gives the tire the black color. It's made out of accelerator to speed up the vulcanization. It has age resistors to minimize the effect of sunlight and water and air. Next step is the mixing material. This is where the raw material mixed in the Banbury mixture. It is heated to about 120 degrees Celsius. The mixing batch is called the master batch. It is cooled and rolled into rubber sheets in the milling machine for further process of extruding stage. Next stage is extruding. This step involves heating the material and sending it through a conveyor to extrude a machine, where the mixture is forced out of a special guide to obtain the shape and thickness it requires. The extruder procedure long sheets of threaded rubber that is cut by the sheaver to the exact tire length desired by the manufacturer. Next process is calendering. The tire cord, fabric, cushion stock, and the inner line stockings are all part of the calendering. They go through a process of spinning cords in the calendering. In the calendering process, these materials are weaved into sheets, then the rubber is squeezed into both sides to insulate them. The sheets then go through a bias cutter to be mechanical cut to specific size and angle to achieve maximum strength, inflation, and stresses. The next process is building operation. In this process, there's two steps. The first step, the woven sheet, the inner line of the body panels, the side walls are aligned. The bead ring is placed on the edge, which automatically crimples and wraps these edges to the bead core, puts the sidewall in position with a continuous rotating movement. After this process, the tire is called a green tire. The green tire is also inflated and applies side threads rubber to the steel belt and cap on the tire as well before it's vulcanized in the next process. In the vulcanization process, the green tire is sent through vulcanization press for about 10-15 minutes where it's heated and it's given pressure at a certain specific heat and pressure to give it durability and resistance. Vulcanization, as you know, is where sulfur is added to increase the durability and the elasticity of the rubber. And the final process of this is to both visually and electronically inspect the tire. Electronic can include machines such as X-ray. This inspection ensures balance, quality, uniformity, and the final product that's shipped to retail right after the inspection. This is just a diagram of the procedure that the tire goes through in terms of the process. We don't have much time today in terms of video, but this is a 3-minute video just showing how tires are made. This is hosted by Michelin as well.
The chemicals involved in the MSDS. Some chemicals involved, textures. Sulfur is used. Some points off the MSDS is that it is flammable. The auto ignition temperature of 450 degrees Fahrenheit. It can ignite at normal temperatures, reactive to hot conditions, and use proper PPE when handling. Styrene butadiene is a non-hazardous substance. Should avoid conditions such as fire sources, direct sunshine, atmospheric precipitation, and heat sources. Can potentially produce toxic fumes when burning. Isoprene, natural rubber. Handling isoprene is not a serious health risk and is not a hazardous material. Should avoid conditions such as fire sources, direct sunshine, atmospheric precipitation, heat sources, and could potentially produce toxic fumes when burning. Silica, chronic health effects when radiative exposure is inhalation. Properties, it appears as a white or tan sand or even ground sand. Generation of silica dust should be avoided. Respiratory equipment should be worn when dealing with large doses of silica dust. Carbon black, black, odorless, insoluble powder that burns at high temperatures, not defined as a dangerous substance. Chronic effects more severe than the acute effects. Respiratory equipment should be worn when dealing with large doses. The end.
And that concludes our presentation. Thank you for watching.